I'm sure you already know that any line segment on the Cartesian plane has two endpoints, and these endpoints have coordinates, right? Yes. We use the displacement between these coordinates to find the length of the vector, otherwise known as the magnitude of the vector. It is written with this symbol, which is called modulus. So, the magnitude of any vector xy is written as modulus of xy. How do we get to calculate the magnitude of xy? We start by tracing out the triangle that is formed by joining the endpoints and then finding the length of xy using the Pythagoras theorem. For example, if vector xy has x and y components as 8 and 6 respectively, this means that the displacement between the x-coordinate at x and the x-coordinate at y is 8, while the displacement between the y-coordinate at x and the y-coordinate at y is 6. Therefore, by the Pythagoras theorem, the square of modulus of xy equals 8 squared plus 6 squared, which is equal to 64 plus 36, and this will give 100. Hence, the modulus of xy is equal to the square root of 100, which is 10. What if the components of the vector happen to be negative? What do you think will be the nature of its magnitude? Let's consider an example. Calculate the magnitude of the vector PR with x and y components minus 3 and minus 4 respectively. Just as was explained in the first example, the displacement between the x-coordinates of P and R is minus 3, while the displacement between the y-coordinates of both points is minus 4. We proceed by substituting the values into the Pythagoras theorem to have the square of the modulus of PR to be equal to minus 3 squared plus minus 4 squared. Therefore, the square of the modulus of PR is equal to 9 plus 16, which gives 25. Taking the square root of both sides, the modulus or magnitude of PR is 5. One thing you must always note is that the magnitude or modulus of a vector is always positive. So generally speaking, the magnitude of any vector v with components x and y is given by the square root of the sum of their squares. That is, the square root of x squared plus y squared. Can you tell me the magnitude of vector s with components minus 5 and 6? Remember that all you need to do is find the square root of the sum of their squares. If you got 7.8, then you are right. Why don't you calculate the magnitude of 20 vectors you can find in your textbook?